Welcome to SDC India 2021 presentation. The topic we have chosen for today's discussion is quality engineering with new era workloads for NVMe over Fabric arrays. I'll be presenting this. My name is Shashikiran Revankar. I'm working as Associate Technical Director at Samsung. Along with me, I have Sandeep and Amit. Sandeep and Amit, kindly introduce yourself.
Hello, good afternoon all. My name is Sandeep Yadav and I'm working as a senior staff engineer in Samsung. Amit?
Good afternoon all. My name is Amit Devgan and I'm working as a staff engineer at Samsung. So the next slide would describe about the disclaimer. So the type of solution mentioned here are for illustration purpose only. So moving towards the agenda of the presentation, I would like to request Shashi to discuss the agenda of this presentation.
Thanks, Amit. So as you can see, first we'll try to discuss about the different type of SSDs and what are the type of interfaces they work with. In this, we will see the different technologies that are there in the SSD. Along with that, we will also try to look at the interpretation of different workloads. By this, we mean we try to analyze the workload in terms of if it is read intensive, write intensive, according to the application. We will also have a look at the details of how these workloads are tested in an environment where we can use NVMe over Fabric. Moving on. So here we are going to show you the different type of SSDs and the interfaces. Moving on. So as we can see that this is a very popular diagram of the NVMe Evolution. In this, we just want to cover the recent development, that is in 2021, the new spec for NVMe is released, that is NVMe 2.0. The NVMe management interface spec is at 1.1b version, and for NVMe over Fabric, it is still with 1.1. Moving on. So here we are going to talk about the different type of NVMe and the different type of technologies within NVMe that are evolving. So the first one is obviously NVMe, and the next one is NVMe over Fabric. So in NVMe over Fabric also there are different transport protocols that are being used, the most popular being RDMA, fiber channel, and TCP/IP. The next type of SSD is KV SSD. This is a very special type of SSD which works on key value pairs, and this aims at reducing latency by removing the file system there. The next one is the open channel SSD, which is mostly popular among the cloud vendors. Another specialized type of NVMe that has recently come into market is the zone namespace NVMe. This tries to adapt some of the SMR technologies from hard drives and improve the NVMe performance. Computational storage drives or computational NVMe are some specialized NVMe which have the controller inbuilt with certain specific operations on the data before writing it onto the drive. So This can do different kind of compression or specific uh, operations on the data before storing it on the drives. Another form of SSD that is evolving is the smart SSD. This has an inbuilt FPGA, which does some kind of specialized function like encryption, decryption, or a different kind of offload. Ethernet SSDs are uh, a type of NVMe SSDs that have inbuilt network interface. These are being considered for highly scalable storage solutions. AIML is another type of new NVMe that is evolving, that has inbuilt machine learning for improving the endurance and performance of the NVMe. GPU Direct is another form of NVMe where the GPU can directly access the NVMe storage data for improved AIML performance. Moving on. Next, we will try to talk about what are the benefits of using NVMe over Fabric. NVMe over Fabric provides very low latency over the network, so this results in overall performance increase for any kind of workload. It can be database, it can be uh, storage solutions. Along with that, NVMe can actually handle multiple parallel requests. So the amount of queuing that we see in the traditional protocols as SCSI or SAS is much reduced. So NVMe can serve multiple parallel requests, which also improves the performance a lot. Along with that, we will also see the implementation of uh, how NVMe benefits in different scenarios. We'll also try to talk about the different protocols that work with NVMe. The most popular ones being the fiber channel, RDMA, and TCP. There are other protocols like iWarp and ISER on which uh, the work is also going on, but the popular ones are these three: fiber channel, RDMA, and TCP. Moving on. So here in this table, we are going to compare the different type of the popular NVMe over Fabric transports, which you can see are fiber channel, RDMA, and TCP. Now, in case of fiber channel, the NVMe commands are encapsulated inside the fiber channel frames and routed through the fiber channel fabric. This solution is popular among the SAN vendors because SAN has been in the data center for a long time. So this technology or this actually is seamlessly integrates with the existing fiber channel environment and also provides the advantage of the performance of NVMe. The next one is NVMe or RDMA. In case of NVMe or RDMA, there is no encapsulation. Instead, the the control plane, the command and responses are transferred using memory semantics like RDMA read write buffer to buffer operations. The next one is NVMe over Fabric over TCP. Since TCP has been there in data centers for many years, this kind of interface provides seamless integration with the existing NVMe TCP environment, and also provides uh, uh, the advantage of using it with existing Ethernet infrastructures without changing or moving it to RDMA. Now, we will also look at how these three different protocols perform. In case of NVMe over fiber channel, since there is encapsulation of the NVMe command in fiber channel format, it imposes certain penalties on the performance. NVMe RDMA is one of the fastest and lowest overhead mechanism for transmitting the data. So this one is supposed to be the fastest one. In case of NVMe over TCP, this provides a seamless integration in the existing environment, but at the same time, it has the lowest performance as compared to fiber channel or RDMA. Moving on. So now we'll talk about the different kind of workloads uh, that can be used with NVMe over Fabric. I would request Amit to take over.
Thank you, Shashi. So as you can see, we are going to discuss about traditional IO tools versus the real workloads. So the limitation with traditional IO tools is that they are fixed IO patterns, but however, real workloads, the value proposition is that we get a real-time IO pattern. IO bursts are not supported in traditional IO tools. However, it is supported in the case of real workloads. Synthetic tools, basically we cannot have a all support of file format. However, real workload supports all file format. Scalability is limited in terms of support with traditional IO tools. However, real workloads have no restriction over the scalability. So moving towards the next slide, we want to understand the interpretation of workloads. So basically, workload is a collection of discrete IO stream. It is observed at specific level of software stack. The access is given to physical or logical storage, and it is done over a period of time. So as you can see, workloads can be classified into 5 major categories. Write-intensive workload is random in nature. It is read-write ratio is 0. Classification could be artificial intelligence, machine learning, and high-performance computing application. Then read-intensive workloads, they are random in nature. Read-write ratio for them is 100. Media streaming comes under this category. Mixed or OLTP workloads are random in nature. Read-write workload for them is 65 ratio, and DB, NoSQL, MySQL, and in-memory web application are some of examples of these workloads. Then video on demand workloads, they are sequential in nature. Read-write ratio for them is 90. Media streaming, high efficiency video encoding are example of that. Composite workload basically are mixed and composite workloads, which have been with the category of big data analytics, virtualization, and software-defined storage. So basically this slide summarizes the interpretation of workloads. Now moving towards the next slide, we would like to share the summary of the workloads which are there for NVMe over Fabric. So as you can see, workloads can be broadly classified into databases, which are SQL, in-memory, and NoSQL, then software-defined storage, containers, media streaming, virtualization, AI, ML, and high-performance workloads, and then is the big data analytics workload. So you can see the logos of widely used applications which are categorized for these kind of workloads. So in the next slide, we would like to discuss details of various workloads. I would like to request Sandeep to discuss about the workloads. And then for this slide, I would like to request Shashi to throw light on Ceph, Lustre, and media streaming workloads. Over to you, Shashi.
Thanks, Amit. So here we are trying to talk about the broad category of type of workloads where NVMe over Fabric can bring the advantage, or it is getting popular. So hypervisors are the most common workload, like VDI environments, virtual machines, or clouds, OpenStack. So this is the one of the primary workload where NVMe-oF can provide low latency and high scalability. Media streaming is another popular type of workload where the read, it is mostly read intensive, and NVMe-oF can provide low latency here as well. Ceph and Lustre are also the most popular storage for highly scalable storage, and Lustre has been there for many years for high performance computing storage. Here also NVMe or Fabric is picking up traction in terms of Ceph and Lustre, and multiple type of research is going on to adapt NVMe-oF into Ceph and Lustre and improve the latency and performance. So in the next slides, we will be discussing how we are going to test, or how do we test these workloads, and Sandeep will be explaining about that. Over to you, Sandeep.
Okay. So in this slide, we are going to talk about the Ceph workload. So Ceph is an open source software-defined storage with no single point of failure. It is highly distributed in nature, and it's also a unified storage. That means it provides all three interfaces, that is block, file, and object. Since it provides all three interfaces, it is also the popular choice for the backend storage for OpenStack deployment. As you know, OpenStack is also used for public and private cloud deployment. The figure shows a typical setup of Ceph with NVMe-oF storage array. NVMe-oF storage disks are mapped to the OSD nodes of the Ceph. By leveraging the NVMe-oF-based storage, Ceph delivers maximum throughput with low latency as compared to the traditional hard drives and the solid-state drives. Moving on to the next. So in this slide, we are going to talk about the Cassandra workload. So that is a NoSQL database. So Cassandra is a scalable and high-performance distributed database, which is used for big data workload, for storing time series data, and for social media analytics. It is widely used in application where write exceeds read by a large margin. Since there is no master node in Cassandra and data placement is done by any node, it can deliver faster performance than some of the other database alternatives available. The NVMe-oF array as a backend storage for Cassandra provides scalable and distributed Cassandra clustered environment, which significantly improves the recovery time as well as the response time during the failure of the node. It also provides higher performance for the write-intensive applications deployed with Cassandra. Moving on to the next. This slide talks about the KVM hypervisor. So KVM is an open source virtualization technique built into Linux. KVM support multiple guest operating systems, including Linux, Windows, BSD, and Solaris. It can run multiple isolated virtual environments called as guest virtual machines. By leveraging the NVMe-oF array as a data store for KVM hypervisor, spin-up time of multiple VMs can be reduced, and a single hypervisor can host more number of VM as compared to hard drive and SSD as their data store backend. Now we move into the next slide. Here we are going to talk about the container workload. So container-based architecture are gaining popularity among large and small companies because they are easier to scale and deploy. Kubernetes is one of the open source application for managing the containerized application across multiple hosts. Kubernetes makes physical storage device like SSD, NVMe, NAS available to cluster in the form of object called as persistent volumes. And now various storage vendors are also developing CSI plugin to expose their storage to the containerized environment. CSI, which is known as Container Storage Interface, is a standard for exposing the arbitrary block, file, and object storage to the containerized environment. By leveraging the NVMe-oF array in a lightweight container platform for the IO-intensive workload, it greatly reduced the latencies and increased the throughput for the various applications that are deployed in your containerized environment. Now I request Amit to talk about the next slide.
In this slide, I'm going to discuss about Chia cryptocurrency workloads. So unlike Bitcoin and Ethereum mining, Chia cryptocurrency farming does not require any expensive accelerator, or it doesn't require graphic cards. So this kind of the workload is emerging and it's a write-intensive workload. So that is the one workload which is currently getting evolved, and there is so much traction about Chia cryptocurrency workload. So the key takeaway from this slide is that we have learned about different NVMe over Fabric protocols which are available. We also discussed workloads for the NVMe over Fabric arrays. How we get these workloads, that is the key outcome of this presentation which we have discussed. So summarizing on the presentation, these are the key takeaways from this presentation. So we would also like to acknowledge our team members. They have given their valuable inputs for this presentation, and we thank for their valuable effort. So please take a moment, give your valuable feedback too. We would be happy to take more any questions which you have, and have a great day ahead and enjoy SDC India conference. Thank you.